right, this is section 8.1, page 1. So the first definition is, what is a region? A region is a closed or bounded portion of a plane. So remember, a plane is like a piece of paper that goes on forever. So you can draw any shape you want. You can have it be curvy, like this, something like that. You can have it something we know, like a rectangle. Or you can have it some kind of crazy shape that, like that. I don't know. Anything you want, okay? So it just means that you've closed it up. All right, so postulate 18, the area postulate. Corresponding to every bounded region is a unique positive number A called the area of the region. Area is measured in square units. So here's a square. It's an inch on both sides, so we call it 1 square inch. All right. Likewise, here's a centimeter. We're going to call it 1 square centimeter. So it's a centimeter on both sides. So 1 square centimeter. So the shape is a square, right? Both sides measure the same. Okay, so when we're talking about an area, here's a rectangle, okay, and it's a closed area. So what is the area of this in terms of numbers? Well, we want to count up the number of square feet we have. And if we count them, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 boxes, and each one is a square. So we want to say we have 15 squares. That's kind of what we want to say, but square what? Well, I know it doesn't look it, but we're calling these feet, okay? So there's another way to write this. You can write it 15, and then you can write feet squared. So this one here, you can say 1 centimeter squared or 1 inch squared. So that's just another shorter way to write it. Okay, so of course we're going to talk about triangles. It says if two closed plane figures are congruent, so they don't have to be triangles, just any closed plane figures. If they're congruent, then their areas are equal. So we would say the area of triangle ABC is equal to the area of triangle EFD. Because the triangles are congruent, their areas are equal. All right. The next postulate says that if you have two figures that don't overlap, then you can just add their areas together. So here we could say, okay, those are two figures that don't overlap at all, so take that area and take that area of the rectangle, area of the triangle, add them together. It's the whole area. Okay, postulate 21. The area of a rectangle. I have a feeling you all know this rule or formula. It says the area of a rectangle whose base is B and height is H is given by, we just multiply them, right? Base times height, you might have heard length times width, either way. The area of a square. Now remember, a square is a special rectangle, so the formula is still going to be the same. Height times base or base times height, but in this case, since they're the same thing, both S's, we say it's S squared. Okay, that concludes page 1.